Hello everyone, good morning. This is lecture number 10 of ODE. So far what we are doing is we have been solving a differential equations of first order and first degree. So in that case we have completed a variable separable method and the equations reducible to the form in which the variables are separated, and we have completed I'll just show you. And then we have completed homogeneous differential equations and the equation reducible to homogeneous differential equations, and then we have completed linear differential equations, right? So we completed 5 methods in solving a differential equation of first order or first degree. Now this is the sixth method, which is called Bernoulli's equation, right? So if you haven't watched all the previous videos, so go through all the previous videos, right? Because then only you will have the continuation of what we are doing. This is lecture number 10. So go through all the previous 9 videos. You will have more clarity. You will have more clarity of what we are doing, right? Okay, super. So in this class, we're going to solve uh, Bernoulli's equation, right? So in this class, we're going to solve Bernoulli's equation. It is whenever equation is of the form something like this, then we will call that as Bernoulli's equation. Now I write down what is Bernoulli's equation and how to solve Bernoulli's equation, and then we will do some problems based on that, right? Okay, super. So everything is visible and audible, right? So to solve an equation of the form, is we're going to solve Bernoulli's equation, right? We're going to call this as Bernoulli's equation. Bernoulli's equation, right? So to solve the equation dy by dx plus py is equal to q into y power n, right? So what is linear differential equation? We will have dy by dx plus py is equal to q only, right? This p and q are functions of x. Now along with this q, we will be having y power n multiplied with q, right? N is some number. N is some number, right? So to solve an equation dy by dx plus py is equal to q into y power n, where p and q are functions are functions of x only, right? So this is called Bernoulli's equation, right? So in a linear differential equation, you will have dy by dx plus py is equal to q, right? So you will not have this y power n multiplied with q. But here in Bernoulli's equation, you will have some y power n multiplied with q. This n is some number, right? This is called Bernoulli's equation, right? This is called Bernoulli's equation. So how to solve this type of equation? That is what I'm going to write down the procedure first. So you just understand the procedure, then everything you can do, problem you can do yourself, right? Okay. So what is the given equation? So procedure, right? So procedure to solve dy by dx plus py is equal to q into y power n, right? Okay. So what I'm going to do is I'm just going to divide both sides. Let us call this as 1, right? So I'm just going to give the general procedure, right? So understand this procedure, problem you can do yourself. So divide by divide both sides by y power n, right? I'm going to divide throughout by y power n. So this will be what? 1 by y power n dy by dx plus py into 1 by y power n is equal to q, right? I'm dividing throughout by y power n, so this y power n will get 1. So this is same as y power minus n dy by dx plus p into y power n minus 1, right? So if I bring this term to upper, you will have, that is, if I bring this term numerator, we will have y power minus n. So y power minus n into y is y power, sorry, it will be 1 minus n, right? Be 1 minus n, right? Y power, this is 1, so 1 y power 1 minus n is equal to q, right? Now remember very carefully, right? Remember very carefully, whatever okay, let us take Let us, I write first and then I let you know, right? Put z is equal to y power 1 minus n, right? Y power 1 minus n. That is, you have to put this term as z, right? You remember this p and q are functions of x, right? That is, whatever y term you have here, right? Very important, very important. I'm saying that whatever you have here, right? That is, you just whatever the term that is multiplied with p, right? That should be taken as z, right? Okay. So z is equal to y power n minus 1. So differentiate with respect to x. Let's call this as equation number 2. So differentiate with respect to x, right? I'm going to differentiate with respect to x. So this will be dz by dx, right? This will be 1 minus n y power 1 minus n minus 1 into dy by dx, right? So x power n formula, n into x power n minus 1 derivative, right? So 1 minus n y power 1 minus n minus 1. Okay. So this will be dz by dx is equal to 1 minus n. This will be what? Y power, this 1 will get cancelled. Y power n dy by dx, right? This implies y power n dy by dx will be equal to, let's bring this term to that side. We will have 1 by 1 minus n dz by dx, right? Let us call this as 3. Now substitute 3 into, right? So put 3 into this in place of y power minus n dy by dx. I'm going to substitute this value, right? So what is 2? Y power minus n dy by dx plus p into y power 1 minus n is equal to q. This is 2, right? So that means dy by dx. Okay. So in place of y power minus n dy by dx, I can write 1 by 1 minus n dz by dx p into this z, right? By assumption y power 1 minus n is z is equal to q, right? So let us multiply throughout by 1 minus n, right? Multiply throughout by 1 minus n. This will be dz by dx plus 1 minus n into p into z is equal to q into 1 minus n, which is a linear differential equation. Yes or no? Which is a linear differential equation. Yes or no? Right? So you can see dz by dx. Remember, this p is a function of x, right? This p is a function of x, and this is a number, right? This is a number. So you will have this is a function of x, and again this is also a function of x, right? Q is already a function of x, and just multiply a number with q, right? No problem. It is a linear differential equation. That means by assuming this to be equal to z, right? By assuming this to be equal to z and differentiating with respect to x, you can get this value, right? You assume this to be is equal to z, differentiate with respect to x, you can get this value. Now with this assumption, this you can say I'm finding y power minus n dy by dx in terms of z's, right? Substituting back here, that means this equation is reduced to a linear differential equation in z, right? In z. Therefore, the solution is what? Solution is what? Z into integrating factor is equal to integration of q into integrating factor dx plus c. Right? Remember, this z is important, right? So z into integrating factor, where what is integrating factor? E power integration of p dx. Right? Remember, this p and q are functions of x here, right? So I'm writing this as p dx. That's it, right? This is how to solve a Bernoulli's equation. After that, in the solution, uh, replace z is equal to y power 1 minus n to get the required solution. That's it. To get the required solution, right? So understand this simple 2 slides, then everything is very easy to follow, right? Then everything is very easy to follow. Is it clear? So to solve an equation dy by dx plus py is equal to q into y power n, where p and q are functions of x only. So whatever, first you divide throughout by y power n to make this coefficient of q. That is, you make this to be a function of x alone. For that, you have to divide by y power n, right? So whatever you have, q is a function of x, remember, right? So whatever you have this y power n, divide that by y power n. So we will have y power minus n dy by dx, y power 1 minus n into p q. So you take whatever term you have with the p, you take that to be is equal to z, right? So z is y power 1 minus n. Differentiate with respect to x, obtain the value of y power minus n dy by dx. Substitute back here, which will be reduced to a linear differential equation in z. Solution is this, right? Is it clear? We'll do some problems now. Solve dy by dx plus y by x equal to y square, right? So you can see, here we have so you can see it is of the form dy by dx plus py is equal to q into y power n, right? Q into y power n, which is a Bernoulli's equation, right? This is a Bernoulli's equation. With what is p? P is 1 by x, q is 1, right? What you have to do? Whatever the term, the RHS part, we have to divide by y square here, right? Usually we divide by y power n. Here our n is 2 here. So what I'm going to do is I'm going to divide by y square, right? So we divide by y square, we will have y power minus 2 dy by dx plus 1 by x. Already we have y, so I'm dividing by y square is equal to 1, right? So we have y power minus 2 dy by dx plus 1 by x y power minus 1 is equal to 1, right? Let us call this as equation number 2, right? Okay. What you have to do, what I have said, you just have to take this term as z, right? That is, this is p here, right? This is p here, this is q. So what you have said, whatever the term you have with p, you take that as y, right? So that means here, you take that as z. So that means put z is equal to y power minus n or minus 1. So put z is equal to y power minus 1. So differentiate with respect to x. So that means this will be dz by dx. So minus 1 y power minus 1 minus 1 dy by dx, right? So minus 1 y power minus 1 dy by dx. This will be dz by dx is equal to minus y power minus 2 dy by dx. This implies you can start getting the value of this term, right? That is what we will do here, right? After putting this to be is equal to z, when you differentiate with respect to x, you will find the value of this entire term. That is what we are doing here also. So y power minus 2 dy by dx value is minus dz by dx, right? Y power minus 2 dy by dx value is minus dz by dx. Now put 3 into. So put 3 into. So you will have y power minus 2 dy by dx value is, okay, let us write that term. So you will have y power minus 2 dy by dx plus 1 by x y power minus equal to, this is our equation number 3. So y power minus 2 dy by dx value is minus dz by dx plus 1 by x y power minus n is z by your assumption, it is equal to 1. So multiply throughout by minus sign here. So there will be dz by dx minus 1 by x into z is equal to minus 1, right? Which is a linear differential equation in which is a linear differential equation in Z. What is the value of P? P is minus 1 by X and Q is minus 1, right? So we have to solve this linear differential equation now, which is very easy. So we know the solution is Z into integrating factor, Z into integrating factor is integral of Q into integrating factor dx plus C, right? So now we'll find integrating factor and then we'll substitute back here. So what is P here? Minus 1. So integration of 1 by x is log x, right? So 1 by x to integrating factor. So substitute back in 4. So z into integrating factor integral of q into integrating factor dx plus is a solution. So z into integrating factor is 1 by x integral of q. So what is q? Q is minus 1. Minus 1 into integrating factor dx plus c, right? Will be z into 1 by x. So minus integration of x power minus 1 dx plus c p z by x minus. So this will be x power minus 2 by minus 2, right? Plus c. Minus minus will become plus, right? Minus 1 plus 1 minus 1 minus 2 minus 2. Okay. Sorry. X, okay. So x power n is equal to x power n plus 1 by n plus 1 provided n is not equal to minus 1. Minus, so integration of 1 by x is log x. X power n dx is equal to x power n plus 1 by n plus 1 provided n is not equal to minus 1, right? If n is equal to minus 1, this will be log x. Okay. So this is a required solution. So you just replace z is equal to y power minus 1 will be 1 by xy is equal to minus log x plus c, the required solution. So if you understand this one problem, every problem you can do in your own, right? So you just see whether it is of the form dy by dx plus py is equal to q into y power n, where p and q are functions of x only, right? Okay. Once again problem. Solve. Q into dy by dx equal to y by x plus y square by x square, right? Okay. So first what we'll do is we'll divide by 2, right? So we'll divide throughout by, okay. Let us first we will write the form. So we have 2 into dy by dx plus minus 1 by x into y is equal to 1 by x square into y square, right? So you can also divide throughout by 2, right? That means you will have dy by dx plus minus 1 by 2x into y is equal to 1 by 2x square into y square, which is a Bernoulli's equation, right? Which is a Bernoulli's equation. So what you have to do? First you have to divide by this y square, right? Divide by y square. So therefore this will be 2 into y power minus 2 dy by dx plus minus 1 by x. So we divide by y square, we will have y power 1 minus 2. So we will have y power minus 2 is equal to 1 by x square, right? equal to 1 by x square. Then what you have to do, put z is equal to this term, you have to put z, right? So put z is equal to z is equal to y power minus 1 and differentiate with respect to x. Therefore, this will be dz by dx. So minus 1 e power minus 1 minus 1 dy by dx. So minus dz by dx is y power minus 2 dy by dx. So put 3 into, so you will have what is 2. So 2 implies 2 into y power minus 2 dy by dx plus minus 1 by x y power minus 1 is equal to 1 by x square. So in place of y power minus 2 dy by dx, I can write minus dz by dx. This minus 1 by x into z is equal to 1 by x square. So divide by 2, right? Because for linear differential equation, you should always have the coefficient of this to be unity. So we'll divide by minus 2. Therefore, dz by dx. When you divide by minus 2, you will have plus by 2x in is equal to minus 1 by 2x square, right? Which is a linear differential equation in z. What is the value of p? P is 1 by 2x and q is minus 1 by 2x square, right? So what is solution? The solution is y into integrating factor, z into integrating factor equal to integration of q into integrating factor dx plus c. So what is integrating factor? Power integration of p dx. So e power integration of, so p is 1 by 2x dx. This e power 1 by 2. So integration of 1 by x is log x, right? So 1 by 2, that means this will be root x, right? E power log x power 1 by 2, which is x power 1 by 2. So root x is your integrating factor. So 4 becomes z into integrating factor, integration of q into integrating factor dx plus c. So z into integrating factor is root x, q into, so what is q? Q is minus 1 by 2x square into integrating factor dx plus c, right? So just take this 2 to the power. So we'll have 1 by 2 minus 2, right? By 2 minus 2 will be z into root x minus by 2 integration of, so 1 by 2 minus 2 by 2 minus 2 will be minus 3 by 2 or minus 3 by 2 dx plus c. So z into root x is equal to minus 1 by 2 or minus 3 by 2 plus 1 by 3 by 2 plus 1 plus c. So z into root x is equal to minus 1 by 2 will be x power minus 1 by 2 by minus 1 by 2, right? Let's see. So this minus 1 by 2 will get cancelled. So this will be what we can do is, okay, that's it, right? So replace z is equal to y power minus 10, which is 1 by y. So you will have root x by y is equal to, this is 1 by root x plus c, the required solution. It's very simple. You can do any problem from now on, right? I'll do another 3 more problems so that you will have more understanding, right? Okay. Solve. dy by dx is equal to x cube y cube minus xy, right? Okay. So you will have dy by dx plus x into y is equal to x cube by cube, which is a Bernoulli's equation, right? So dy by dx plus py is equal to q into y power n. P q. This is a Bernoulli's equation. So first what we'll do is we'll divide by y cube, right? We should always have function of x only here. That means this will be y power minus 3 dy by dx plus x into y power minus 2, right? So divide by y cube, 1 minus 3 is minus 2, is equal to x cube. Right? Let's call this as equal to 2. So whatever you have here, you have to put that as z, right? Suppose z is equal to, put z is equal to y power minus 2, right? That is in terms of whatever you have with p. So here p is x here, right? So p into y. So just have to put that as what? P into y power minus n. This is what procedure is, right? So whatever you have with p, just take this n term to be is equal to z, right? Along with p. So that means differentiate with respect to x. So you will have dz by dx is equal to minus 2 minus 2 y power minus 2 minus 1 dy by dx, right? That means the value of y power minus 3 dy by dx is, let us bring this term here downside. So we will have minus 1 by 2 dz by dx. So put 3 into, so you will have what is 2? So 2 is y power minus 3 dy by dx plus x into y power minus 2 is equal to x cube. That means this term will be minus 1 by 2 dz by dx x into z equal to x cube, right? So you have to always have this to be unity. So what I'm going to do is about divide by minus 2 throughout. It will be dz by dx plus minus 1 by 2x into z is equal to minus x cube by 2. I'm just, sorry, I have to multiply by 2, right? Sorry. So multiply by minus 2. Multiply by minus 2, this will become unity. Will become minus 2x, will become minus 2x cube, right? Which is a linear differential equation, right? Which is a linear differential equation. This is a linear differential equation in z with what is p? P is minus 2x, q is minus 2x cube, right? Q is minus 2x cube. So therefore the solution is y into integrating factor is equal to integration of q into integrating factor dx plus c. What is integrating factor? E power integration of p dx, e power integration of, so p is minus 2x dx, e power minus 2, so integration of x dx is x square by 2. So e power minus x square, right, is the integrating factor. Substitute back in 4, y into integrating factor, sorry, it is not y, it is z, right? So integration of q into integrating factor dx plus c, right? So whatever you use is a linear differential equation in z, right? That means you will have z into integrating factor as solution. Okay. So z into integrating factor is e power minus x square. Integration of what is q? Q is minus 2x cube into integrating factor dx plus c, right? So you can take this minus 2 outside. So what we can do is you can also assume t to be is equal to x square, or you can also do integration by parts, right? Or you can also use some substitution here. So put t is equal to minus x square. Therefore dt will be minus 2x dx, right? Minus 2x dx. So therefore this can be written as minus 2x into x square, right? I'm just writing x cube as x into x square, e power minus x square dx plus c, or else can also do integration by parts. Take some time. You have to do 3 times integration by parts, right? Or you can also use Bernoulli's formula also for finding this integration. Or you can use substitution method. It will be integration of the minus 2x dx is dt. This will be minus t, right? Minus t e power d dt plus c. Or no, because x square is minus t. So minus t e power t dt plus c. Take this term outside. So integration of udv t into e power t dt plus c plus will be uv minus integration of vdu. Very simple, right? So u is t here, dv is e power t. That means du will be dt, v will be e power t. E power t dt is will be minus u into v. So u is t, v is e power t. Integration of v du. So v is e power t. Again e power t dt's integration is e power t. Right? Therefore the solution is, now again you replace z is equal to replace t is equal to minus x square and z is equal to y power minus 2. You'll get the solution, right? Solution is, so here you will have z into e power minus x square. So what is z? Z is y power minus 2. That means 1 by y power 2 e power minus x square minus t into e power t. So t is minus x square, right? So minus x square. I can take this e power t outside. So you just replace minus e power t. So e power t is minus x square into t power into t minus 1. Right? The required solution. Right? Very simple. I think you can do any problem from now on, right? Bernoulli's equation. The fourth problem. Okay, so we want to fourth problem. So solve dy by dx minus 2y tan x is equal to y square tan square x, right? So you can see again it's a Bernoulli's equation, right? Dy by dx plus py is equal to q into y power n, where p and q are functions of x, right? So we have dy by dx plus py. So minus 2 tan x into y is equal to tan square x into y square, which is a Bernoulli's equation. This is a Bernoulli's equation. First, we will divide by y square, right? So we are dividing by y square to make the RHS only as a function of x. So you can see here we have tan y square here, right? So whatever you have with the q, you have to divide by that. So divide by y square, you will have y power minus 2 dy by dx plus minus 2 tan x y power 1 divided by y power 2. So y power 1 minus 2 is minus 1 is equal to tan square x. Let's call this as 2. So put z is equal to y power minus n. Therefore, dz by dx will be minus 1 y power minus 2 dy by dx, right? Differentiating with respect to x. So we will have this implies y power minus 2 dy by dx is minus dz by dx. So put 3 into, so we will have y power minus 2 dy by dx minus 2 tan x into y power minus n is equal to tan square x. This is our q. So this is our equation number 2. So y power minus 2 dy by dx is minus dz by dx minus 2 tan x, this is z, is equal to tan square x. So we will always make sure that this is unity. Coefficient is unity of dz by dx. So multiply throughout by minus. So we will have dz by dx 2 tan x into z is equal to minus tan square x, which is a linear differential equation in z, right? So p is 2 tan x, q is minus tan square x. The solution is given by z into integrating factor, integration of q into integrating factor dx plus c. What is integrating factor? E power integration of p dx. So e power integration of p dx. So p is 2 tan x, right? P is q 2 times tan x dx. E power 2 integration of this log cos x, right? Sin x by cos x dx. Derivative of cos x is minus sin x. So minus is missing. We will multiply by minus. So this will be e power minus 2 log of cos x, right? E power minus 2 log of cos x. Let's take this minus 2 to the power. E power log of cos x whole power minus 2. This is e power log x is x. Cos x whole power minus 2, which is 1 by secant square x, right? So 1 by cos square x. 1 by cos square x, which is secant square x. By cos square x. This secant square x is your integrating factor. So solution is z into integrating factor equal to integration of q into integrating factor x plus c, right? So z into integrating factor integration of what is q? Q is minus tan square x. Integrating factor is secant square x plus c. So put t is equal to tan x, right? So put t is equal to tan x. So therefore your dt will be secant square x dx, right? Tan x derivative is secant square x. That means secant square dx can be done as dt will be integration of tan square x will be t square dt. So minus t cube by 3. So minus replace t by tan cube minus tan cube x by 3, right? So replace z is equal to y power minus 1, right? By y. So that means 1 by y secant square x is equal to minus tan cube x by 3 plus c. Right? Minus tan cube x by 3 is the required solution. Right? All also very easy. If you understand the procedure, you can do any problem yourself, right? So we'll do fifth problem now. Solve dy by dx is equal to e power x minus y into e power x minus e power y. Right? E power x minus y into e power x minus e power y. So first what we'll do is we'll multiply this e power x minus y inside. So this will be e power x minus y into e power x, e power x minus y into e power y. So this will be e power, I'll just add it. So 2x minus y, e power 2x minus y minus e power x, right? This e power y and this e power minus y will get 1. So e power x minus y plus y, this will be e power x. So you will have dy by dx is equal to e power, let's write like this, right? E power 2x into e power minus y minus e power x, right? Okay. Let's bring this term to here. We will have dy by dx plus e power x is equal to e power 2x into e power minus. So usually you will have you can see this dy by dx plus px p usually what we will have is dy by dx. Bernoulli's equation is, if you can see, dy by dx plus py is equal to q into y power n. But here we will have something different, right? So p is e power x here, but we don't have y here. That is y power 0 is here, right? Y power 0 is here. And here we will have, instead of y power n into q, you have e power minus y into q, right? Instead of y power n into q, you will have e power minus y into q. No problem, right? Okay. So what we will do is we will divide throughout by e power minus y. But this is not Bernoulli's equation, but we can follow the same approach here. Right? Okay. So divide by e power minus y. This will be e power y dy by dx plus e power x into e power minus y is equal to e power 2x. Right? E power 2x. So what I'm going to do is put this term to be equal to z, right? Put z is equal to e power. I'm approaching by same method, right? Okay. So put z is equal to e power minus y. Differentiate with respect to x. That means dz by dx is equal to derivative of e power minus y is what? Minus e power minus y dy by dx, right? Power minus y minus, okay. That means e power minus y dy by dx. Okay, so we are getting e power minus 8. Okay. So I think what we can do is e power y dy by dx. Okay, we are dividing by e power minus y, right? So that means it will be e power plus y only. Dividing by e power minus y, right? We bring this numerator, you will have plus y only. Okay. Now you can see e power, let's call this as equation 2, call this as 3, let's call this as, so put 3 into, so therefore you will have e power y dy by dx is dz by dx plus e power x into z is equal to q, right? E power 2x, which is a linear differential equation in z with what is the value of p? P is e power x, and what is the value of q? Q is e power 2x, right? Okay. Solution is y into integrating factor, z into integrating factor, z into integrating factor is equal to q into integrating factor dx plus c. Now to find integrating factor, we have e power integration of p dx, e power integration of p dx. So p is e power x dx. So e power x, right? So e power x is your integrating factor. Substitute back in 4, z into integrating factor, integration of q. Q is e power 2x into integrating factor dx plus c, right? Will be integration of e power x, e power x, e power x dx plus c. So put t is equal to e power x. So therefore your dt will be e power x dx. So e power x dx is dt will be integration of t into e power t dt plus c, right? T into e power t dt plus c. This uv minus integral v du. So you will have t e power t plus e power t, right? This is a required solution. So uv minus integral v du. Right? U to put u is equal to t, dv equal to e power t dt. So therefore your du will be dt, t will be e power t, uv minus integral v dt this term. So replace t is equal to e power x. Just take e power t outside, t minus 1. So z into e power x. So replace what is z? Z is e power y. Replace z is equal to e power minus y and t to be is equal to e power x. So you will have e power y, e power x, e power x is equal to e power x, e power x minus the required solution. Right? Now you can use the same approach what we did in the previous case. Any doubt? I think we can do any problem from now on, right? So I give you some exercise problem in Telegram group. I'll give you some exercise problem in Telegram group. Very easy problem, right? So you just have to divide this by term to make this coefficient, to make the RHS part only in terms of x. That will be converted to Bernoulli's equation. Put z is equal to this term, differentiate with respect to x. So you will have the value of this term. Substitute back here. You will get a linear differential equation in z. Solution is z into integrating factor is equal to integration of q into integrating factor dx plus c. So find integrating factor, substitute back here, and get the required solution, right? Very simple problem all are. Okay, so I'll give you some exercise problem in Telegram group. So we'll wind up Bernoulli's equation. The next class we're going to move on to exact differential equation, right? Exact differential equation. Okay, so it's in the next class. Thank you. You can download the PDF of this section Telegram group, right? Okay.